Our class, we're going to learn about breadboarding electronics and how to properly connect and find values of resistors and make things work. And in my opinion, this is one of the funnest units because you get to build stuff and make it do stuff. My favorite. All right, breadboard. A lot of you may have never heard of these before, but these are just prototype boards where you can plug wires in and components and put a battery up to it and make things work and do some fun things and build some projects. It's sometimes called a prototype board, but it's a breadboard and it's just a reusable platform to build electronic projects. So it's cheap, less time, less money. A PCB board is something that you use to finalize your prototype. Once you've figured out exactly how to make things work, you want to put it onto a PC board and solder it and make it permanent. So this also lets you simulate, observe how and if the actual circuit will function. These prototype boards give designers the ability to quickly change components, test capacitors, swapping out resistors for different values and stuff like that. And how to move back and forth voltage and change the current and resistance without soldering. All right, so this is how the inside of a breadboard looks, and you'll notice that there's these wire strips in rows, and then there's wire strips in columns. The ones in columns are meant to connect your wires from your battery coming into your project, and your project is in the center, in the rows in the center. All right, columns and rows are connected. So columns are connected. You have a plus and minus coming in from the battery. And then your components will plug into those columns, into the rows where you put them. And you want to make sure that the connectors on your components are in different rows. You don't want both connectors from the same component in the same row, or you're gonna short circuit it and it's gonna burn out, or it just won't work all together. So you want to make sure both connectors on your component, which can be an LED or resistor, are in their separate rows. All right, so this is kind of counterintuitive, but we're going to be actually doing it the bad way. We don't want to be using wire cutters to cut wires. These wires I'm going to give you guys, once we do this in a lab, they have like these little pins on the end of them that make it easy for you to plug them in. And once we start cutting wires, they get frayed and they don't go in the breadboard as well. So we are going to refrain from using the wire snippers. All right, so you want to make sure the breadboard closely resembles the layout of your schematic that you've written up, or that you've looked at from a wiring magazine that you want to build something that you found in a magazine or something like that. Use the schematic to check to make sure component wires are added. And the last bullet, basically you're going to have the Tinkercad program check to see if your circuit works by whether or not it actually comes on or not. All right, so in this PowerPoint they really only talked about the cathode. You got the anode and cathode. The long wire is hooked up to the positive, and the short wire, the cathode, is hooked up to the negative. So current only flows through LEDs and diodes in one direction, and so you want to make sure that the wire coming into this LED comes from the from where the current is flowing from, and then where the current is flowing to, you want that hooked up to the shorter wire, the cathode. All right, so to make sure you don't burn up LEDs and diodes, you can actually put too much power through them. You can actually, they'll pop, and you get glass everywhere. The LEDs will just kind of melt. First they'll smoke, then they'll melt. By the time when they're smoking, the teacher is running in your direction, trying to figure out what's going wrong. And by the time the teacher gets to you, the LED is already smoked up or burnt up, potentially on fire because you put too much power to it. And it only takes about 1 second for that thing to go out. You'll see the LED come on and then immediately go off. So then your teacher will ask you, please throw that LED in the trash after it stops smoking, because if you throw it back in the pile with all the good LEDs, you're not going to know. You'll have to test all those LEDs, and we got tens of thousands of LEDs. We don't want to throw our bad LEDs back into the good pile. All right, so you can see they have color bands, and that little symbol in the middle is the symbol on a schematic for resistor. And the bottom bullet, resistance is measured in ohms. So to figure out how much resistance you need, let's say with a 9-volt battery for a just one LED that's rated at a certain measurement, you want to know what the minimum resistance value is that you'll need to put in that prototype to keep that LED from smoking and catching on fire. Okay, so you got several different types. We're going to be dealing mainly with the two top ones there. And they got the symbols on the left-hand side of them. The potentiometer, you can see the little arrow coming into the squiggly line. That's potentiometer is basically you're able to adjust that by turning the knob left and right, increasing and decreasing the resistance. The one to the left is mainly what we're going to be using, and those have the bands that tell you the resistance value, and you can change those out pretty easily. And with resistors, it doesn't matter which way the current flows through them, they're still going to work. So it doesn't matter how you read them to get the value, but it doesn't matter which way the current flows through them. All right, so to measure the value, use a multimeter on the right, and you can also use a multimeter to figure out where the bad LED is at in your prototype. So let's say you have 1,000 LEDs. One of them goes bad. If it's a series circuit, nothing's going to work until you find that LED. And you just use a multimeter to track that down. All right, so how to read a resistor value? Read left to right. So first band's going to be the first number, second band's going to be the second, and then the multiplier all the way from 0.01 all the way up to 1,000 mega ohms, and we're not going to be going that high, or to the very lowest, we're not going to go that low. We're maybe going to deal with 1K, 10K, 100K, maybe a little bit of projects done with the 1 mega ohm blue. All right, so example number 1. So the first band is going to be brown, so that's going to be 1. Second band is black, so that's going to be 0. Multiplier is going to be red, so it's going to be 10 multiplied by 100, or 10 multiplied by 100 ohms, plus or minus value of tolerance of 5%. So 10 times 100 is 1,000 ohms. But when we write that down, we're just going to say 100K ohms. K is stands for 1,000, so 1 times 1,000 is 1,000. So we just write 1K ohm. And most of the projects you're going to be doing, if you deal with 9 volts, 1K ohms is the upper limit to the resistance value that we're going to be putting on our prototypes. So you want to, most of your resistance are going to be below 1K ohm. Okay, so the second value, or second example is you got orange, which is 3. Second is going to be 9, so 3, 9. Multiplier is green, so that's going to be 39 times 100K, or 100,000. So 39 times 100,000 is 3,900,000 ohms, or 3.9 mega ohms, with a plus or minus of 5% on the tolerance. Example number 3, 1.5K ohms. So the first digit is going to be brown. The next one is going to be green. All right, so brown and green times 1,000. Brown, green. I'm sorry, not times 1,000. It's going to be 3 positions to the right, which is going to be 100, which is red. Let's see if I'm right. Yep, brown, green, red. Okay, so 1.5K ohms is 1,500 ohms, or 15 times 100, which is red. And that's going to be a brown, green, red, and gold. I know that doesn't really look good like gold. That's what throws me off sometimes. I'm looking at a resistor that's been in my toolbox for 10 years. I mean, the colors do kind of fade a little bit, and then the gold starts to look like yellow, and you're reading this resistor backwards. But if you get the wrong value of resistor, how do you find that out? If you got it read backwards, is you put in put it on a multimeter, and that'll quickly tell you that you've got that thing backwards. And there's your multimeter. Okay, so these things are kind of fragile, and depending on how many we have in the lab, I have actually seen the lab. This is actually the month of July right now. And so once I see how many we have of these, we're going to go into a lengthy lesson on how to use these properly so we don't burn these things up. Of course, you do have some pretty cheap ones that you can get at Best Buy that are like $10. This thing right here is about $80. So they have some that are between $5 and $10, where they just have a simple connector. You put the component on there, it tells you what resistance is, and those things are probably something I'm going to insist on having in my classroom, because they burn up about 1,000 less times than you would if you use this. And if we get to the point where we can actually function proficiently with these things, then I'll let these loose in the classroom. And we're going to be doing a lot of this stuff. We're going to learn it now. We're actually going to be doing some soldering toward the last 4 or 5 weeks of the school year. So right after spring break, we'll once we've gotten through all the other stuff, we'll make a return to electronics and actually do some hands-on soldering with PCB boards. But we have to do some safety lessons and stuff like that so that we know how to use all this stuff without getting hurt. Because when you actually solder, if you don't ventilate the room properly, you can actually get a headache with that, the smoke and stuff. So anyway, let's see what's next here. So that's it on that first lesson for breadboarding and finding the values of resistors. This gets easier as you go along, but we're going to do some calculating of the voltage drops and why LEDs get dimmer and dimmer as you go hook up more and more components. You can see voltage drops, and then you'll determine, okay, well, if I have all these components and all these resistors in there, and everything is going dimmer and dimmer, how do I make that where I keep my components, and how do I calculate the proper amount of voltage I need at the start of the prototype to make everything function properly. So that is for future lessons, and I'll see you in the next video.